Hello math learners, so for today's video, we're going to proceed in Newton's law of motion. So ito naman, wala tayong prerequisite ngayon kasi sisimulan pa lang naman natin siya. Siguro the only prerequisite you can, we can tackle is the resultant vector and the scalar and vector quantities. So for more information about this lesson, watch this video till the end. So let us start. So in Newton's law of motion, this is just an introductory that we supposed to discuss first before the resultant vector and the scalar and vector quantities. So what are the Newton's law of motion to be discussed? So number one is we have law of inertia, law of acceleration, and law of interaction. So we have only three laws. Of course, we all know that this exists because of Isaac Newton. Okay. So I know everyone might curse our Sir Isaac Newton because of this one. That's why as student, we are suffering because of this. You're the beginning of the suffering of you when you are studying physics. Okay. Okay, so let us start. First one is we have the Newton's first law of motion, which is the law of inertia. Unless acted upon by an unbalanced external force, an object at rest tends to remain at rest, and an object in motion tends to continue moving with the same pace and direction. I just remember the one quote I just have read. Like, it is also applied to students. The student is remain at rest until the deadline arrive. Okay. So, how are we going to apply this in real life? Let's just say we have the coin on the cardboard attached on the glass. Okay, the coin will remain at rest or stay at rest, putted on the cardboard, so still at rest. Ayan, the coin is at rest on the paper or the cardboard, whatever it is. Mukha siyang cardboard eh, bakit pa? Okay, so the coin remain at rest. As you can see, the coin exert to the paper is going down. Okay, and also the force, the gravitational force that retain the coin on the paper. Kumbaga, parang pag ganun siya, let's just say this is the coin. Let's just imagine that is the coin and this is my hand. Paano ko ba siya yan? Okay, as you can see, yan, that my pods or the coin on the picture remains at rest because this one exerts force going down to my hand, that my hand lift up my bod or the coin up, which means it is unbalanced. Not until I let go of this one. Like this. If I just going to throw like that, that means an object in motion tends to continue moving the same pace and direction. So how are we going to make this move? It's either if we flip the paper or we flick the paper. What will happen if we flick the paper or we just pull? Kasi ang force ko dito dyan sa figure, papitik. Okay? Ito naman, ganun ang gagawin natin. Pero somehow, pwede rin naman natin mapagalaw ang coin if we're going to pull the paper out of it. Like this one. Once you flick the paper, there must be two consequences. The paper will out, then the coin will fall to the glass, or the paper will out together with the coin. There's two consequences as long as you tend to move the coin. Okay? Once the paper, like this one, the paper, kapag ganyan, pinitik nyo, babagsak yung coin. Okay, ganun lang siya. The coin will fall into the glass. But somehow, it just depends the way you flick the paper. The movement of the coin is just depend of how you're going to move the paper. Maybe if you flick too hard, I guess, maybe the coin will join together with the paper when you flick it. Okay. So we are done in first law of inertia. Second one is we have the Newton's second law of motion, which is the law of acceleration. So the rate of change in an object's momentum is directly proportional to the net force and occurs in the direction in which the force is applied. Excuse me. So mathematically, this law can be stated as F is equal to ma, or force is equal to mass times acceleration, where if the net force applied on an object, m is its mass, and a is the acceleration produced. This law essentially tells us how the motion of an object changes when a force is applied to it. Okay, sabi nga dito, object's momentum is directly proportional to the net force, the mass, and your F. Since law of acceleration, pag dinerive natin siya, F over m, a, where mass is inversely proportional to acceleration. So let's have this object. The mass 1 and the force. You see the exert, that how the boy exert force to the box. So for more understanding, let's have another situation. There's two boxes, and we all know this is that the second one is heavier the first one. Excuse me. Okay. We all know that mass is the mass and the acceleration is directly proportional to the force. Okay. The boy exerts this, it will be the same as the acceleration, or getting higher. The forces we exert, the higher the acceleration we will get. Okay? But however, that mass 2 is greater than 1, and force 2 is greater than the force 1. Sabi nga natin, ano siya? Directly proportional. So kung ano ang taas nito, tataas din to. Okay? However, the acceleration, why is the first one is the boy exerts more acceleration than the second one? Kasi mas magaan to eh. Excuse me. Mas magaan to. Mas magaan itong part na to. Kasi sabi dito, mas mabigat to. According dito. So, same din ang i-exert niya sa force. Pero, mas naka-accelerate siya dito. Kasi mas magaan naman talaga, mas halimbawa, sa pagbubuhat ng mga bagay. Let's just say, if I've just carried my phone, I can also use my phone while I'm running. Okay? Unlike, if I just lift up this whole closet where I attach, let's just say if I'm going to lift up this closet that where am I put my iPad on. Di ko to kaya buhatin. Kaya ko siyang buhatin kaso hindi natin siya kayang buhatin na tumatakbo tayo. Okay? Ganun lang 'yon. So, sabi nga natin, the higher the mass, the lower it accelerates. So vice versa. Kung the lighter the mass, the higher the acceleration we will get, or we will exert. Excuse me. Ganun lang. So, in conclusion, ayan, kagasasabi ko lang, the higher the mass and the force, the lower the acceleration, vice versa. Next one, we are done in second law of motion. Let's have in law of action and reaction, or interaction. So, this Newton's third law of motion simply states for every action, there is an equal and opposite reaction. Para lang yun sa totoong buhay, pag sinuntok kita, syempre gaganti ka, diba? Parang ganun lang din yon. Okay? Halimbawa, sinuntok kita, tapos susuntokan mo rin ako, diba? Ganun din yon. I exert force to you by punching you, and you just do the same to me. Ganun lang siya. Okay? This law states that if object A exerts a force on object B, then object B will exert an equal and opposite force on object A. So, these forces always occur in pairings and exert their influence onto distinct objects. Gamitin natin yung kaninang force. Pumili tayo dun sa isa sa dalawa nung kanina dun sa second law. Ito. Bawa itong part na to. Yung boy has an action, exert force on the box. Tinutulak niya. Okay? Ganun din sa box. The box exerts force on man. Kumbaga, nagano siya. Parang equilibrium, sabi rito, di ba? Ngayon, bakit nahihirapan pa rin yung... Parang sa bawat forces nyo, lumalaban yung object na inaano nyo, na ginagalaw. Let's just say my phone. How can I lift up my phone? Hindi ba lumalaban yung cellphone ko na force sa akin? Lumalaban siya. But the force of the phone exerts on me is lighter than mine. Kasi mas malakas ako kung tutusin sa cellphone ko, so kaya ko siyang buhatin. Let's just say this makeup kit. Nabubuhat ko siya. Bakit? Sabihin natin yung makeup kit na itong forces niya pa dito. Kaya pag binitawan kayo, babagsak talaga yan. Okay? Lumalaban naman. Ibig sabihin, pag binagsak ko ba ito, walang lalaban. Meron. Yung gravity of the earth. Walang joke. Yung gravity. Kaso, the gravity is lighter than this one. Okay? Ngayon, hawak ko siya. Hindi ba siya lumalaban? Kasi hawak ko siya. Hindi siya bumabagsak. Lumalaban siya. Pababa siya, kaso mas mataas lang yung force ko. Kaya ko siya nahawakan. So, pag binitawan ko yan, naging mas lighter yung force. Ngayon, mas higher yung forces na ito kaysa sa gravity. Ganon. Imagine lang natin na meron siyang force. Pero sa totoong buhay, hindi naman natin maano yun. Kasi ang gravity of the earth, pababa eh. Okay. Ganon lang ang naging concept ng action and reaction. Parang dito lang, that man exert a force, tinutulak niya yung box. It doesn't mean ba syempre lumalaban yung Kaya sabihin natin natutulak niya, may nagagalaw niya. Kaso, lang dito ko, anong mas malakas sa dalawa. Minsan di natin maano rito kung nagagalaw niya ba. Kasi kung di niya ito na-move, ibig sabihin, mas malakas yung force na ito. Unlike dito. Ganun lang yun. Vice versa. Kung mas malakas to, malamang matutulak niya yung box. Kung hindi ibig sabihin, wala siyang buto. Sabihin, may buto siya, mas malakas lang nga lang to. Ganun lang. Okay? So, well done. So, hopefully, you like my video today for the for the first to third law of motion. So, that's for now, and thanks for watching, and see you in my next video.